All right, so you've got that coding interview coming up, and let's be real, those whiteboard moments, they can feel like a mental obstacle course, you
Hmm.
know? It's like you know your stuff, but how do you actually show it under pressure?
It's true. The way you think about the problem often matters more than just having the perfect code snippet memorized.
Exactly. It's about showing off those problem-solving skills, and that's where this deep dive comes in handy. We dug into this guide, Mental Models for Problem Solving, a cheat sheet for cracking coding interviews. And it really digs into the mental frameworks that interviewers are looking for.
It's fascinating how this guide emphasizes that these models can be even more valuable than rote memorization. It's like training your brain to approach problems in a whole new way.
Totally. So let's jump right into it. They start with recursion trees, and I'll admit, recursion always felt a bit like magic to me. But the guide uses this really cool example, the Fibonacci sequence.
It's a classic example that nicely illustrates the power and potential pitfalls of recursion.
Right, like you can write a simple recursive solution for Fibonacci, but it can be really slow.
Yeah,
And the tree visual makes it so clear why.
exactly. Each node in the tree represents a call to the function, and with the Fibonacci sequence, you end up making the same calculations repeatedly. It's like retracing your steps multiple times on a maze.
And that's where the aha moment hit me. When you see the recursion tree, all those overlapping subproblems become obvious. It's not just about getting the Fibonacci numbers, it's about showing you understand why the naive recursive approach is inefficient.
Absolutely. And that's a huge flag to interviewers. They want to see you can analyze the efficiency of your code and look for ways to optimize.
Makes sense. Okay, so next up we've got dynamic programming. Now, I'll be honest, this one always sounded a bit intimidating to me.
It can sound daunting at first, but the core concept is actually quite intuitive.
Okay, I am all ears. How does the guide break it down?
Well, think about it like this. Imagine you're trying to solve a complex jigsaw puzzle. Dynamic programming is like breaking that puzzle down into smaller, overlapping pieces. You solve each smaller piece just once and store the solution. Then when you encounter the same piece again, you just refer to your stored solution.
So instead of repeating the same work over and over, you're saving time and effort. I like that.
Exactly. And that's what we call memoization. It's like your brain, or in this case your code, remembers the important bits so it doesn't have to keep recalculating them.
Okay, that actually makes a lot of sense. It's like having a cheat sheet for your code, but instead of cheating, it's just being smart.
Precisely.
Mm.
And interviewers love to see that kind of clever optimization. It shows you're thinking about writing efficient and elegant code.
All right, dynamic programming. I'm starting to see why this is a favorite. But what about when you're dealing with a problem where you need to explore different possibilities, kind of like a choose your own adventure for code?
That's where backtracking comes in. It's a powerful technique for exploring all possible paths to a solution.
So, kind of like a detective trying out different clues until they crack the case.
Exactly. Imagine you're a detective trying to solve a complex crime. You might start with a suspect, follow a lead. If it doesn't pan out, you backtrack and try a different approach.
And this helps you cover all your bases, making sure you don't miss any potential solutions.
Precisely. The guide uses the classic N queens problem as an example. Imagine you have a chessboard, and you need to place N queens on the board so that none of them can attack each other.
Okay, I remember that problem from my computer science classes. It's trickier than it sounds.
Right. But with backtracking, you can systematically try placing a queen in each position, and if at any point it leads to a conflict, you backtrack and try a different position.
Yeah.
It's all about exploring the problem space in a structured way.
So instead of making random guesses, you're using logic and a systematic approach to find the solution.
Exactly. And that's something interviewers really look for, the ability to break down a complex problem into manageable steps and demonstrate a clear logical thought process.
This is all starting to make a lot more sense. Okay, so we've talked about recursion, dynamic programming, and backtracking. What about when we need to process data within a specific range or window?
That's where the sliding window model comes in. Think of it like using a magnifying glass to focus on a specific portion of a larger data set.
Okay, I'm picturing it. Can you give me an example?
Sure, imagine you have a long string of numbers, and you need to find the subarray of a certain size with a maximum sum.
Okay, I can see how that would be useful. So instead of calculating the sum of every single possible subray, which would be really time consuming.
Exactly. With the sliding window approach, you start with a window of the desired size, calculate the sum, then slide that window one element at a time, updating the sum as you go.
So you're only focusing on the relevant portion of the data at any given time, which is much more efficient.
Precisely. It's like moving a spotlight across a stage. You're only illuminating the part that needs your attention. And this efficiency gain is a major selling point for interviewers.
All right, sliding window, got it. Now, what about those situations where you need to work with two separate parts of the data simultaneously?
Ah, that's where the two-pointers technique shines.
2 pointers, it sounds elegantly simple. What's the idea here?
It's all about using two pointers or indices to efficiently traverse through a data structure, often an array or a string. This allows you to perform operations or checks on two different parts of the data at the same time.
So it's like having two sets of eyes scanning through the data looking for specific patterns or relationships.
Exactly. And it can be surprisingly versatile.
Mm.
For example, the guide talks about how you can use this technique to reverse a string in place.
Okay, so how does that work with 2 pointers?
Imagine you have a string. Let's say hello. You start with one pointer at the beginning of the string pointing to H, and another pointer at the end pointing to O. Then you swap the characters at those positions and move each pointer one step closer to the middle. You repeat this until the pointers meet or cross, and voila, you've reversed the string.
Wow, that's pretty slick. It seems like a really intuitive way to manipulate data.
It is, and that's part of what makes it so appealing. Interviewers appreciate solutions that are not only efficient, and also elegant and easy to understand.
This is great. Okay, we've covered a lot of ground already. What's next on our list of mental models?
Well, things are about to get a little more interconnected, literally, as we dive into graph traversal.
Graph traversal. Okay, I'll admit that one sounds kind of intimidating. Like, are we talking about those diagrams with circles and arrows, the ones that always made my head spin in math class?
You got it, but trust me, it's not as scary as it sounds. Think of it like navigating a network of roads. Each intersection is a node, and each road connecting them is an edge. Graph traversal is simply about finding ways to systematically explore all those roads and intersections.
Okay, so far so good. But why is this relevant to coding interviews or even just like real life?
Well, imagine your Facebook, and you need to find the shortest path between two friends in your network. Or your Google Maps figuring out the fastest route from point A to point B. That's graph traversal in action.
Ah, now you're talking my language. So how do we actually do this graph traversal thing?
There are two main approaches that the guide highlights: depth-first search, DFS, and breadth-first search, BFS.
Okay, those sound familiar vaguely. Remind me what they're all about.
Imagine you're exploring a maze. DFS is like taking one path as far as you can go, even hitting dead ends before backtracking and trying another path. BFS, on the other hand, is more like exploring all the paths from your starting point one step at a time before moving on to the next level.
So DFS is like the determined explorer who leaves no stone unturned on a single path, and BFS is more methodical, checking all options at each step.
Exactly. And each approach has its strengths depending on what you're looking for. DFS is great for exploring all possible paths and finding cycles, while BFS is better for finding the shortest path between 2 points.
This is making a lot more sense now. Okay, so we've tackled graphs, but what about when we need to find a specific piece of information within a larger set of data? I feel like there should be an efficient way to do that.
You're absolutely right. That's where binary search comes in. It's a classic divide and conquer strategy that's incredibly efficient for searching sorted data.
Okay, I'm intrigued. How does this divide and conquer thing work in practice?
Imagine you're looking for a specific word in a dictionary. You wouldn't start at page 1 and flip through every single page, right?
Definitely not. I'd probably open the dictionary somewhere in the middle.
Exactly. And that's what binary search does. It starts by looking at the middle element of the sorted data. If the middle element is what you're looking for, great. If not, you eliminate half of the search space based on whether the element you're looking for is greater than or less than the middle element.
So you keep narrowing down the possibilities until you find what you're looking for. Kind of like that game 20 Questions, but with data.
Precisely.
Yeah.
And because you're having the search space with each step, it's incredibly efficient, especially for large data sets.
That's brilliant. Okay, we've covered a lot of ground with these models, but there's still one more on our list, right? The mysteriously named state machines. What's that all about?
Ah, state machines. They might sound complex, but they're actually quite intuitive once you grasp the concept.
Okay, I'm ready. Break it down for me.
Think about it like this. Imagine a vending machine. It has different states, right? There's the waiting for money state, the dispensing product state, the giving change state, and so on.
Yeah, that makes sense. Each state represents a different point in the vending machine's process.
Exactly. And it transitions between those states based on specific inputs or events. So if you insert money, it transitions from waiting for money to dispensing product. If you press a button for a product that's out of stock, it might transition to an error state.
So you're essentially mapping out all the possible states and transitions for a system.
Precisely. And this can be applied to all sorts of things beyond vending machines. Think about game logic traffic lights, even the software that controls a microwave.
Wow, state machines have gone from zero to hero in my mind. This deep dive has been eye-opening. We've covered so much ground: recursion trees, dynamic programming, backtracking, sliding window two-pointers, graph traversal binary search, and finally state machines. It's like we've unlocked a whole new level of problem-solving skills.
It has been quite a journey through these mental models. And you know what? What's even more fascinating is how these models often interconnect.
You're right, like that example with graph traversal. You could totally use a combination of these models to solve a single complex problem.
Exactly. And that's what makes this whole approach so powerful. It's not about rigidly sticking to one model, but rather about having a toolbox of mental frameworks that you can draw from and combine creatively.
So to our listeners out there, if you're prepping for those coding interviews or even just looking to up your problem-solving game in general, definitely dive deeper into these mental models.
They're not just for acing interviews. They're valuable tools for thinking more effectively in all areas of life.
Couldn't agree more. All right, folks, that's a wrap on our deep dive into mental models for problem solving. Until next time, happy coding, and remember, keep those brains engaged.